Hello and welcome to Let's Learn .NET Blazor. Good morning, good evening, good afternoon, good late evening, good early morning, wherever in the world you are joining us. We are so grateful that you are spending your really important time with us here today. I am really excited about this topic. We're going to talk about Blazor. We're going to talk about all about how to get started in Blazor, what Blazor is, why you should use it, what's important for it, why it's important to you. And then we're going to go ahead and build a really fun game app, web app with that, a Connect 4 app. So I'm going to go ahead and bring on our host, Daniel Roth. So let's go ahead and add you to the stage. Woohoo!
Hi,
Hey, Daniel,
Jayme.
how's it going?
Oh, it's great. It's great to be here.
Yay. Yeah, thank you all. I'd love to see in the chat where you all are joining from. What time zone are you calling in from? I'm calling in from New York. What about you, Daniel?
I'm on the west coast of the U.S. I'm up by in Washington.
There we go. All right, we're on either side of the coasts in the US, and we're going to talk about Blazor. So let's go ahead and pull up your slides first.
Great. Let's do
Cool.
it.
Sweet.
Exciting. Yeah.
All right. Okay, so let's go ahead and get started.
All right. So I'll just go ahead. We ready to go?
Yeah,
Let's start
I think we're
learning some
ready. I
stuff.
think we're ready.
All right. Well, welcome everyone. It's so great to have you all here. I'm Daniel Roth. I'm the product manager for Blazor at Microsoft on the .NET team. And today we're going to learn Blazor together. Let's learn some Blazor, going to learn some .NET. We're going to build some web apps. We'll build multiple apps as part of this session today. This is meant to be a live interactive coding session. So please, engage with us in the chat, ask questions. Get ready to code on your own developer machines. We're going to set up your environment and start working directly hands-on with Blazor today. The goal is by the end that we will have built this Connect 4 application at the end, a little game where you can drop the checker pieces and try and get 4 in a row. You may remember this from your childhood. Like Jayme said, you can find the Learn modules that we're going to be going through today at the Learn collection link that's on the screen at aka.ms/let's-learn/.net/Blazor. We're actually going to go through a few modules. We'll work up to this Connect 4 app. So we'll learn, basic Blazor concepts on the way. We'll get your whole machine set up and go from there. Like I said, live and interactive. If you have any questions, go ahead and post in the chat. Jayme will let me know, and we'll try and handle those live or in the chat directly if we're still in the middle of doing a demo or going through a particular concept. Prerequisites for this learning session, really none. Like if you just have a desire to learn Blazor, then you're in the right spot. Maybe you want to get into web development, you want to build your first web app. Maybe you already have some experience with .NET or web development with other frameworks. You want to see what Blazor is like. Doesn't matter if you're here to learn. We're going to start you at the beginning and then build up from there. So you don't need to really have any previous experience with Blazor, not really any previous experience with .NET. Maybe some basic understanding of what a web app is, and that's just about it. Our learning objectives today is that we're going to understand what Blazor is and how it works, and understand when should you use it. Like when is it a good fit for particular projects. We're then going to set up our machines and actually build our first Blazor app, start playing around with it, learn about Blazor components and how they work. We'll customize the appearance of our applications using standard web technologies like HTML and CSS. And then by the end, we'll have hopefully built that Connect 4 game. The agenda for the whole session is we'll start out with going over the basics of Blazor. We'll configure the environment. We'll build the app. We'll then go through all of the different features of components like handling events and data binding, what the Razor syntax is and how you use it. We'll build that Connect 4 game. And then at the end, there will be a test. There will be a knowledge check. So, pay attention. Make sure you're listening. Jayme, you too. We might ask you a few questions as well. And then we'll wrap up at the end. You should have completed 3 Blazor Learn modules by the end of this session. There's the introduction to web development with Blazor, build your first web app, and build the Connect 4 game. These are all part of the Blazor learning path, which you can actually find at aka.ms/Blazor/learn. Once you've completed these 3 modules, you're of course welcome and encouraged to continue your learning journey by completing the rest of the modules as well. But we'll at least try to get through these 3. Okay, and I think we're ready now to talk about what's Blazor. I'm actually going to pop off of this screen real quick, and let's go over to the web, to the web browser. First thing I want to make sure everyone's aware of is the Blazor homepage. You can get here at blazor.net. That's the back up, there we go. That's the magic URL for the Blazor homepage, and that will bring you to this site. And this is where you can learn all about what Blazor is and find useful resources like the docs and simple getting started tutorials. You should have this link to the collection, the Learn collection for this session today. And here are the links to the 3 specific Blazor learning modules that we're going to be doing. And then, like I said, these are all part of the Blazor learning path. You can see there they show that the first 2 show up at the top. The last one's actually all the way at the bottom, but there's lots more modules in here that you can do, learning about routing and layouts and forms and validation. So, the learning doesn't stop here, but hopefully this will get you going. Okay, and the first one we want to do is the Introduction to Web Development with Blazor. So go ahead and get this module open on your machine, browse to the collection, click on that first link. It's this one right here, and that will bring you to this first learning module. Now, the goal of this first learning module is just to help you evaluate whether Blazor is a right fit for you. What is it? How does it work? And when should you use it? So by the end of this, you should know if Blazor's the best fit for your next project. We think it is great for doing web development. So go ahead and click on Introduction. Choosing building web apps these days is a complicated process. There are a lot of options for using for frameworks for building web applications. Many front-end JavaScript frameworks, React, Angular, Vue. There are server-side frameworks like Django with Python, or using Java or PHP. How do you choose? How do you pick which framework you want to use for building your next great web app? So in this module, we're going to go through what are the benefits of using Blazor. What is it and what can it do? How does it accomplish those benefits? And then when is it a good fit? And maybe when is it something you should consider a different option instead? An example of a web app that you can build with Blazor is shown here below. This is a pizza store application where you can pick a pizza that you want to order and then configure it with the toppings that you like. You can see that it has a sign-in button, so it supports authentication. You can then submit your order and track your order. If you go through the rest of the Blazor learning path, you will learn how to build this sample application. We're not not going to be working with this particular app today, but this is something that you can aspire to in the future. This is the kind of web app that you can build with Blazor, as well as enterprise applications, internal line of business applications, and so on. Blazor is a great solution really for building any type of web application. Okay, all right, so go ahead and click next to get to the next unit in this module. So what is Blazor really? Well, Blazor is a modern front-end web UI framework, okay? And it is full stack. It's designed to help you build great full stack web apps fast. It's based on standard web technologies like HTML, CSS for actually defining the UI on the screen. But for writing your logic, Blazor uses C#, a modern, strongly typed programming language that makes it easy to write code that's correct and fast. So Blazor is a modern front-end framework based on HTML and C#. When in a Blazor app, you use components to build up your application from reusable parts, little UI widgets that you can assemble into a broader application. It's part of the .NET platform. Like it's in there. If you've ever installed .NET, then you have Blazor available to you to develop with. It's built into the .NET platform as part of ASP.NET Core, our broader web framework for .NET. And that means that if you use Blazor to build your next web app, if you're learning C#, you're learning web development through Blazor, you're actually set up to now build applications using .NET that can go anywhere. Like you could use .NET to now build a desktop application. You can use your C# and .NET skills to build mobile apps. You can build cloud native applications. You can build games. You can build, AI intelligence-based applications. It's all available with the .NET platform. It's really a platform for building anything. It's free, it's open source, and it is cross-platform. Your .NET code can run on Windows, on Mac, on iOS, on Android, and on Linux. Now, some of the benefits specifically of using Blazor, let's go through a few of them. Blazor, like I said, is based off of components, and that makes it very fast to assemble your UI. Blazor comes with a bunch of built-in components for forms and validation, for handling large virtualized data sets. And then there's the ecosystem of Blazor components that you can then go out and download and use, install as NuGet packages, so that you don't have to build every single UI element of your application yourself. Blazor uses C#, and C# is an awesome language to program in. Fewer bugs by having strong typing and lots of modern language features. You get one development stack when you build your web app with Blazor. Blazor can run from both the server and also from the client, like in the browser. So it's a full stack web framework. You use one language, one framework, one set of tools in order to build the entire application. There's no real need to have like a separate front end and back end team when you're a Blazor developer, because you can do it all. You can do your development full stack. Blazor has an efficient diff-based rendering engine. When we render your Blazor components, Blazor keeps track of the parts of the HTML DOM that have actually changed, and then only applies the changes to those parts of the DOM, and that makes your UI updates very quick. Like I said, Blazor supports both server and client-side rendering, so you can both render your components from the server in response to requests, and you can also execute them client-side in the user's browser and access all the features of the web platform that the browser provides. Blazor provides enhanced server-side rendering capabilities where you can progressively enhance a page from being just a statically server-rendered page to having enhanced navigation, streaming rendering patterns, so that your app feels rich and interactive when it's actually still being fully powered from the server. While you typically write your Blazor app using C#, if you need to use JavaScript in your Blazor application, you can do that too. You can grab an existing JavaScript library and call into JavaScript from your C# code, and the opposite is true. You can call from JavaScript back into .NET. You can even grab existing JavaScript components and render them in your Blazor app as custom elements. Blazor has great tooling support in Visual Studio and Visual Studio Code, so you get an awesome editor with IntelliSense and debugging and all those great productivity features. And Blazor is also not just for the web. If you want to take your Blazor components and reuse them, like in a native mobile and desktop app, you can do that too using an approach we call Blazor Hybrid. It's a hybrid of a native client application, like a native mobile app, iOS, Android, or a native desktop app, combined with web UI technologies. You basically reuse like a embedded web control to render your components from within that native application. So with one framework, you can actually target mobile, desktop, and web using a single set of components. So that's all the things that Blazor can do, why it's a great fit. Let's go ahead and go on to the next one. So how does that work? Like, how does Blazor do all those things? Well, a Blazor component encapsulates its UI rendering logic. Like, it renders HTML, and you can have C# code that determines what HTML shape it wants to produce. You can also use C# in order to handle UI events. Like when a person clicks on a button, you can have code execute in your Blazor component, which then changes its state and changes what UI it then renders to the screen. So those components can then be built into reusable .NET libraries that can be shared, not only with your application, but with other applications as well. You're using just standard web technologies when you build a Blazor app. So it's HTML, CSS, and then C#. How does the C# code run? That's not usually, it's not part of the web platform. You think of browsers, they can normally run JavaScript code. Well, the way Blazor enables C# development is in a couple different ways. We can see that down below. The first way is by setting up this WebSocket connection, a real-time connection with the browser, and executing the C# code from the server. So if you have UI events that happen in the browser, Blazor will just send those to the server, run your C# code, run the components remotely, and then send those HTML DOM diffs back down to the browser so that the UI can be updated. This is what we call interactive server rendering, and it's a pretty unique capability to Blazor, to have interactive web apps that are being fully powered from the server. You can also run your Blazor components directly from the client via WebAssembly. Well, what is WebAssembly? Well, WebAssembly is a low-level bytecode for the web. Browsers used to only be able to run JavaScript. Well, that's not the case anymore. They can also run this low-level bytecode format called WebAssembly. And so what we can do with Blazor is we can take your .NET code and run it in a browser using a small .NET runtime that's implemented in WebAssembly. Alternatively, you can actually also just compile your C# code, your .NET code, all the way to WebAssembly. It's called ahead of time compilation, and have it just run in the browser as WebAssembly. Both those models are possible. So that's how we can get Blazor code to run client side. Okay, so that's how it works. It's just standard web. You don't need any plugins to your browser. You don't need any extensions or proprietary tech to make this work. You're just using the modern open web in order to get your Blazor web apps to work. Here's an example of what a Blazor component looks like. This is a simple counter component, and we'll be looking at this a lot when we go to build our first Blazor web app. But if you're curious, like, what does this code look like? Well, you can see it's just mostly standard HTML. Like, this is just a normal H1 tag. But then when you want to add logic, you can add C# code. Like, these are just C# members on a class that's being generated from this this component code. Here's a place where we're taking one of those like a C# field and rendering its value into the HTML. And when you want to handle UI events, you can do that by pointing to C# methods instead of having to deal with JavaScript. Okay, so that's how it works. But is it a good fit? Let's go ahead onto the next unit. Is this the right framework for you? Well, Blazor is designed to handle the needs of most modern web apps. Whether it's the right fit for your next project will depend on a number of factors. If your goal is to build something fast and to be highly productive using a full stack web development solution, Blazor is great. Super productive, great tooling, builds stuff quickly. It removes the need to have like separate teams that handle the back end and the front end, like where you in some cases you might have a .NET team that handles the back end code, but then you have to have a separate JavaScript front end team to handle the front end code. With Blazor, you can have everyone be a full stack web developer. If you're already doing .NET development, then Blazor is obviously a natural choice because you can take your existing skills with C# and .NET and carry them forward to front-end web development. It's not a requirement to be a .NET developer already to use Blazor, but if you already are one, then it can be a very compelling solution. Also, for high-performance back-end code, there's really nothing that compares to .NET. Like, .NET is a top-notch framework when it comes to server execution. So if you're running, highly intensive server workloads, you really want to squeeze out as much throughput from your servers as possible and keep those, costs of running the service down. Using .NET and Blazor for your server-based workloads is a great option. Blazor might not be a good fit if you're trying to really optimize the download size of your web application. Like, you really care about every single byte that goes from the server to the client. Remember, we said that to run Blazor code in the browser, you need to download that it's a small but still additional .NET runtime implemented in WebAssembly to get it to execute in the browser. If you want to do client-side execution and you really don't want that overhead, you're really trying to make that page load as fast as humanly possible, Blazor might not be the best option. If you're already heavily invested into an existing JavaScript framework like React or Angular or Vue, whatever, and you have lots of existing components that you're using, then maybe you would stick with the stuff that you've already got. Although you can take Blazor components and reuse them from existing front-end applications. And lastly, Blazor does utilize the modern web platform. It uses modern JavaScript features. It uses WebAssembly. If you need to target really old browsers, and I mean old, think like IE old, Blazor's not going to really function well in those old browsers. So you might need an alternative framework that only requires, a minimalistic web platform functionality. Okay, so let's see what we've learned. Let's do our first knowledge check. All right, so first question, what is Blazor? Is Blazor a way to run .NET code on WebAssembly?
it this way.
Native UI framework for building Windows desktop apps, a modern front-end web framework based on HTML, CSS, and C#, or a type of jacket resembling a suit jacket, but with a more casual cut. Jayme, what do you think? What is it?
Well, a blazer, as far as a jacket, is a tempting choice. But I am actually going to go with C, a modern front-end web framework based on HTML, CSS, and C#.
That would be correct. Good job, Jayme. Yes, yes.
Yay!
First question accurate. Some people might be tempted to pick this first option. You know, Blazor, particularly in its early days, Blazor was all about that new capability of running .NET code in a browser and WebAssembly. And Blazor does enable that, but that's not all that Blazor does. Blazor is a full stack server and client web UI framework. Okay, next one. What language do you typically use to author Blazor components? Do you use JavaScript, XAML, Visual Basic, or Razor syntax?
Ooh, that's a hard one. I'm wondering if anyone is gonna beat me to it in the chat. Okay, so what language do you?
So it's not JavaScript like that. If you were going to do JavaScript, you would use a front-end JavaScript framework. Blazor is based on .NET. XAML, if you've never heard of XAML before, like XAML is a very .NET specific native UI technology. So like a way to define native UI with like XML. So it's not that. I haven't talked about VB at all. The answer must be
gotta be Razor. And when you hear Blazor, I feel like Razor is like they go hand in hand. You hear them almost synonymously. So
fun story. I think when the name Blazor, the developer that originally built the first Blazor prototype and gave it its name, he said it was a combination of browser and Razor, because Razor was a syntax that we've had in .NET for a while, which is a nice mixture of HTML and C#, like we saw in that counter component. And so people asked him, like, where'd the L come from? And he said, well, originally he joked and said, well, blockchain. Like, no. Blockchain was all hot at that point. He said, no, I just sounded nicer and I stuck the L in. Yeah. So Blazor is really browser plus Razor. So you use Razor syntax, a combination of HTML and C# to build your components. All right, true or false? You can use existing JavaScript libraries with Blazor.
True.
True, absolutely. There's JavaScript interop support in Blazor. Which of the following benefits is not a benefit of using Blazor? Is it building web UI fast with reusable components? I think we said that was a benefit. So it's not
that is a benefit.
Support for server and client-side rendering. Blazor can do that. That's a nice feature. Build the front end and back end with one development stack. That's a lovely thing. I see a hand. I know
the answer. Okay, so it's minimal download size, because you did mention that if you were concerned about that, then that may not be the best option for you, because it does have a bit of a download.
Blazor is not trying to be the absolute smallest front-end web UI framework. It strives to be good enough and to focus on productivity. Like, I'm really making it so you can build that app as fast as possible and have a good load time, but maybe not like, tens of kilobytes. Like it'll be a little bit bigger than that. So if you're trying to win the lightest weight app contest, then Blazor might not be your best choice. Okay, so which of the following reasons is a valid reason to not use Blazor? You need to use an existing React component in your web app. You need to host your web app on a cheap static site host like GitHub Pages. You're not a C# expert, or you need to support older browsers. Let's go through those. Ooh, so a React component. Can you use a React component from Blazor?
Yes.
The answer is yes, actually. Like, React supports rendering components as custom elements. You can just render a React component in a Blazor app like any other HTML tag. So yeah, you could use a React component in Blazor. If you have lots of React components, you might not want, you end up doing more React than Blazor, then maybe you should just be using React. But if you're talking about just like a couple, then it's totally fine. Cool. You need to host your web app on a cheap static site host like GitHub Pages. Can you host a Blazor app as a static site?
Yeah, I believe you can.
Yes, the answer is yes. Blazor supports it's called a standalone Blazor WebAssembly app, where it's just a bunch of static files where you download the WebAssembly runtime, you download your component code, and it runs purely client side. No server pieces required. So Amazing. You can host a Blazor site without really any .NET server piece at all. So it's not that one.
Very cool.
You're not a
It's
C
definitely
sharp.
not that. So it's got to be D.
C sharp. C sharp's a great language. If you don't know C sharp, you should take the time to go ahead and learn it. So yes, the last answer is the one that's is about a valid reason to not use Blazor because of older browsers. So let's check all our answers. Ta-ding! All right, we got it all. Okay, so we have passed that you've just completed your first Learn module, everyone.
Hooray! Congratulations, everyone.
Points. Claim your achievement if you haven't done that already.
Achievement points.
You're well on your way. Do we have any questions so far, Jayme, that we need to do?
Yeah, we do have some questions that I'd like to get to before we kind of move on to the next section. So let me just mark a few more of these just to capture all of them. So we've got some great questions here. So first question, are there any Microsoft apps that were built using Blazor?
Are there any Microsoft apps that were built using Blazor? That's a great question. So we have at Microsoft, we use Blazor a lot internally. Like we have all sorts of line of business applications that are built using Blazor, like our I think we've shared publicly before, like our insider trading compliance application for like people, not me, like people who have lots of Microsoft stock and need to follow laws and regulations about when they sell their stock. That app was built using Blazor. The app that's used to like manage employee identities internally at Microsoft is built in Blazor. The Xbox team has portals that they've built in Blazor. The Azure folks have portals they've built in Blazor. So it's used a lot internally. In terms of like public-facing products of Microsoft, a lot of what Microsoft does for front-end development these days, honestly, is actually based off of React. And that's mostly for historical reasons. Back in the day when like the Office team was trying to build the Office web apps, there was no Blazor, so there wasn't even an option. They actually, most of the .NET the Microsoft products on the back end are heavily using .NET. And there's a lot of great blog posts on the .NET blog talking about the amazing performance gains and savings that they realized by using .NET on the back end. But for the front end, many of the major Microsoft products were actually built with React like a long time ago, and there's quite a big React community at Microsoft. I mean, Microsoft's a big company. We actually have developers in pretty much every developer platform that you can imagine. Go, Rust, JavaScript, TypeScript,
Python,
.NET, of course, and Java. So we've got every kind of developer you can imagine at Microsoft. But we are starting to see products use like our .NET WebAssembly capabilities, like in the Power platform. I think it's the Power Virtual Agent Studio uses .NET on WebAssembly to handle like expression parsing. Recently, we announced .NET Aspire, which is a framework for building cloud-native apps with .NET, and the portal in .NET Aspire for viewing your traces and your metrics and your telemetry. That was built entirely using Blazor components, and that is actually in the process of being moved into some of our Azure services so that portal is available more publicly. So yes, we do use Blazor at Microsoft. There's a lot of JavaScript as well, so I'm not certainly not only a Blazor shop. I would say actually, majority on the front end at Microsoft is still using JavaScript, but there's an active and passionate Blazor community internally at the company.
Oh yes, very, very passionate. We use it a lot for our demos and everything, so we use it a lot. Which actually, speaking of React, do you have any tips on getting front-enders who like Vue and React to look into Blazor?
Getting them to want to look into it.
Kind of like transition over.
Why? Like, come over here. Come to Blazor. We have cookies, like that sort of thing.
Hey, we have cookies.
I think the big selling point with first of all, Vue and React are great front-end frameworks. Like they're very mature, and if you're using those frameworks, you should not feel bad. Like there are lots of great options for building front-end web apps these days. With Blazor, I think the really compelling thing is how is the productivity experience, like the end-to-end development experience of being in Visual Studio or Visual Studio Code, having the great IntelliSense and tooling experience around C#. The ease of getting started to set up your environment and F5 in just a few minutes, and also making sure they know that, and you don't have to throw away your React stuff or your Vue stuff. You can reuse that even within your existing Blazor application. That's what I would say. But you know,
That's the pitch.
there are lots of developer frameworks. I don't think we're not fooling ourselves that like every single React developer is suddenly going to become a Blazor developer. Like you know, use the right tool for the right job.
Yeah. And then to kind of follow up on that is, for those who don't know, does Blazor support Linux?
Linux. Oh, I was going to say it's Linux. What's Linux?
Yeah, I believe that's supposed to be Linux.
Absolutely.
I'm going to go ahead and.
.NET all up supports Linux. You can use .NET to run server applications on Linux. I mean, Blazor is for building web apps. So the UI that you're running is running on the web platform. It's running in a browser. So if you have a browser on your Linux machine, then yes, you can view a Blazor-based web application just like you can any other web application. But yes, Linux is absolutely supported. Mac OS, Windows, iOS, Android. .NET is cross-platform.
DB.
All right, we should build our first web app. We got to get some code.
Yeah, we got to get moving.
All right, here we go. So we're going on to the next module. You should now move on to build your first web app with Blazor module. The goal here is to configure your local environment so that you can build Blazor apps. We're going to create your first Blazor web app, and we're going to start playing around with some components. Let's go ahead and get started. Introduction. You're at the right place if you're trying to build a Blazor web app. And this module, this basically says all the things that we're going to do. We're going to browse, plow right through that. So how do you get set up to start using Blazor? You basically need, at a minimum, the .NET software development kit, the .NET SDK. The .NET SDK has the .NET runtime, and then it has tools and templates that you can use for creating a Blazor project and then building it and running it and publishing it. You, at a minimum, need the .NET SDK to get going with Blazor, but there's also really great tooling experiences available with both Visual Studio and Visual Studio Code. With Visual Studio, that's a full IDE that is only on Windows, so you have to be on a Windows machine to use it, but it has great debugging experience and lots of integrated tools for working with .NET projects. Visual Studio Code is a lighter weight text editor, but if you install the C# Dev Kit extension, you can get a great editing experience. There's lots of, a really nice ecosystem of extensions that you can then add to your Visual Studio Code environment to facilitate writing code. So if you prefer the sort of more lighter weight text editor, Visual Studio Code is great. If you want a full IDE, the Visual Studio IDE on Windows is the solution we'd recommend. If you install Visual Studio, it comes with the .NET SDK, so you don't need to install it separately. Visual Studio Code, you'll need to install the .NET SDK as a separate download, and then make sure you enable the C# extension. So let's do it. All right, I'm going to let's start with the most basic thing. Let's start with the CLI experience. So the first thing you're going to want to do is get the .NET SDK so that you can actually run Blazor code. This is assuming you don't already have Visual Studio. And to get .NET, you want to go to keep missing my button. .net. Okay, that's the .NET homepage. That's where the Blazor homepage lives on this site. Okay, so you go here, you click download, and you get the .NET 8 SDK. Get that onto your machine so you can create Blazor applications. And once you have that, if you go open up a command prompt, you should be able to type .NET --version, and the version that comes back should start with an 8. And I have a preview version of VS, which has a preview version of the latest .NET 8 SDK. So I've got a big, long, messy looking version number. But the key thing is to make sure that it says 8 dot something. If you've got that, you're good to go. If you get an error, then go try installing the .NET SDK again. Something didn't quite go right. You might have multiple versions of the .NET SDK installed. That's okay. You can see them by doing .NET list SDKs. And you can see on my machine, I have the stable release of .NET 8 and then this new preview version that should be coming out shortly. Okay, so once you've got that, you should be good to go with building and running .NET projects. I'm going to go to my desktop. And to create a Blazor app, you can use the .NET new command. Right? .NET new is how you create a project from the .NET command line interface, or CLI. And there are lots of templates that are available. What is it? I think if you just type .NET new, it lists a bunch, and you can create Blazor web apps, class libraries, console apps, and so forth. I want to create a Blazor app, so I'm just going to do .NET new Blazor. And if you just type that, it will create the project in your current directory. If you want to tell it where to put it, then to -O for output and give the project a name. I'm going to call mine Blazor app. All right. And that should create our Blazor application. and it should now be there on disk. There it is, Blazor app. Now, to see this, I'm going to go ahead and open it up in Visual Studio Code. I have that installed on my machine. If you want to install Visual Studio Code and you don't already have it installed, you can get it by going to code.visualstudio.com. Okay, that's the magic URL for getting Visual Studio Code, and that will get you the text editor. Okay, but you'll want to add an extension. So just click on the download button to get Visual Studio Code. It's a very quick install. You'll want to add also one extension to Visual Studio Code. You click on the extensions button, and you'll want to install this guy right here, the C# Dev Kit extension. You can just search for it in the marketplace up above and install it. I've already got it installed, but you're going to want that if you're working with .NET projects in Visual Studio Code. Okay. And if we have that extension, then not only can we see all the files that make up our Blazor web app project, but down below there's this Solution Explorer tab that will show up. And this will give us a project level view of our Blazor web app project. This is how .NET sees what's this project is made up of. Okay. So there's all the code, and we'll dig through this a little bit later. But for right now, I just want to get it to run. I want this app to be executing. How do I do that? Let's go back to the command line. To run the project, you can just go into the project directory. So cd Blazor app, and let's give ourselves a little more space. And you can just run the command .NET run, and that will build and run the Blazor web app, and then you're done. A better approach that I'd recommend is actually to run .NET Watch. .NET Watch is a little tool that will not only build and run your project, but it'll also watch the project for code changes so that it can apply those code changes to the running app as you're developing. So you run .NET Watch, you then just go and code and then leave it running while you're making your updates. I'm actually going to run this from the Visual Studio Code terminal by hitting Control backtick to bring up a terminal. And I'm going to run .NET Watch from right here. And let's see if we can get that going. All right. So it's building my project. And then it started. Okay, and it starts, once it starts, it will automatically open the browser for you. And there's our first Blazor web app. Hopefully you've got this running on your machine too. So we've got a few different pages. We've got the home page. We've got a counter with a button that we can click and the count goes up. And then we've got this weather page that displays a list of weather forecast data. All right, so simple little sample application. Let's go ahead and get this side by side with Visual Studio Code. And let's give ourselves a little bit more coding space so we can see what's going on. Okay. I don't think we need the terminal anymore. Well, the thing I want to show you is how you can just edit a little bit of code. Like if we go into this components folder and go into pages, we can find the code for this home page in home.razor. Blazor apps are made up of Razor files. And then let's just change this H1 right here. We'll just add a bunch of exclamation points. Visual Studio Code will automatically save, and we can see that we've got some exclamation points up top. You know, if we want to change the text, no problem. Yeah, you did it. And then that should now update as well. So that's .NET Watch doing its thing. It's applying the code changes to the running app live as you make the changes in your code. All right, so that's great. So that's how you can use .NET Watch to get your app running using just the .NET CLI, and you can start making code changes using whatever text editor you like, honestly. In this case, I decided to use a Visual Studio Code. Let me go ahead and hit Control-C in the terminal to stop the application from running. Now, with Visual Studio Code and that C# Dev Kit extension installed, we can also debug the application from within Visual Studio Code. And the way you can do that is by just hitting the Run and Debug button. Let's go ahead and click that. And it's going to ask you, well, what kind of debugger do you want to use? I want to use the C# debugger. Generally, it's it should be your only choice. And then it'll ask about what debug configuration do you, which launch profile do you want to use to run the app, and just pick the default one, the first one at the top. Okay. And then once that's done, we should be able to now click the Run button and get this running from within Visual Studio Code. There's our application running again. And if we go to this counter where we have this button that we click and the count goes up, let's go find the code for that counter that, logically lives in the counter.razor. And there's this code that we saw earlier. I'm going to click on this left-hand side and put a breakpoint right here in this increment count C# method. That's the method that's being called every single time we click the button. So now if I go back to the counter and I click, nothing happens, but that's because we just broke into the debugger, and we can now, look at the value of our variables. We can see that the current count is 3. You see that right there? And we can step through our code and understand what's going on. So that's how you can run and debug from Visual Studio Code. Currently with Visual Studio Code, while you're debugging, if you need to make code changes to the app, you're going to have to restart the application. It doesn't support what we call hot reloading changes into the running app. So you either use .NET Watch if you want to see the code changes apply as you're making them, or you get debugging currently in Visual Studio Code. You don't really get both, but we can get both if we go over to VS, which we'll do in just a second. Visual Studio Code can also create the Blazor web app project for you if you want. The way you can do that is by first bringing up the command palette, which is Control-Shift-P, and then you type .NET and pick this first option, .NET, create a new project. If you select that, it should bring up the list of .NET project templates that are in the .NET SDK, and you just look through here, look for the Blazor web app template, and that's the one right there. You then give it a name and go forth, and that will create the project for you right from within Visual Studio Code. I think there's also another way to do that. Where is it? There's another spot someplace where you can also create a new project. But anyway, the control panel palette is the easiest way to do that. Control palette, just search for .NET and create the new project that way. Okay, so that's how you can create a project from Visual Studio Code and also run and debug. I'll also show Visual Studio. I'm gonna go ahead and close this. So with Visual Studio, you can get Visual Studio from visualstudio.com. I think /downloads is probably the easiest place to, is downloads or download? I can't remember. Download. Yeah. And this will give you the links for installing full VS. And there is a free version of VS for community use and open source use. So you can go ahead and download and install that. I've already got that installed. When you install Visual Studio and you want to build Blazor apps, because Visual Studio is this IDE that can do C++, it can do all sorts of different kinds of .NET projects. If you want to do specifically Blazor, when you run the Visual Studio installer, it will ask you which workloads do you want to include in the Visual Studio installation. If you only, and I've got a couple different versions of VS, I'm going to modify the stable one, which is this one at the bottom. You'll see this UI. And so you pick which kinds of apps you want to be able to build. The only one you really need for Blazor is this ASP.NET and web development workload. Just make sure that checkbox is checked, and then you click install, and Visual Studio will set you up with everything you need to build Blazor applications. And then once it's installed, you can go ahead and launch it. And to create a new Blazor project, you click create new project. This will list all the project templates that are available in the SDK. You can see Blazor web app is right there at top. That's the one we're going to want to use. This one right here. If you don't see it, you can always search for Blazor, and that will show you all the Blazor templates. And just make sure you pick the Blazor web app template. That's the one that we're going to be using today. So we can go ahead and click that. Click next. Give your Blazor web app a name and decide where you want it to go. This will be my second Blazor web app apparently. Click next. Actually, I want to go back. I want this to be just Blazor web app. If I can keep the name the same. Yes. Okay, good. Now, on this additional information page, Visual Studio is going to give us a bunch of options of ways that we can create this template. The first option is, well, what version of .NET do you want this app to run on? Make sure you pick .NET 8. We're going to use the latest long-term support version of .NET. That will have all the fancy new features. And there's a bunch of options here for setting up authentication and what interactive render modes we want. Just leave the defaults for all these other options. Leave them as they are. So this should be server for the interactive render mode and per page or component for the interactivity location. And then it will, by default, include some sample pages for us, like that counter and the home and the weather page. If you don't want those, you can uncheck this checkbox. But for now, go ahead and leave them checked and just click Create. And then Visual Studio will create Blazor web app project for us. We can see all the code in the Solution Explorer over here on the right. And then we can go ahead and click the green button up at the top to run this app with debugging. And the nice thing about Visual Studio is that not only can we run and debug, but we can also then edit and see the changes live. So let's get the app going. Where'd it go? My screen. Oh, there it goes. Okay, so here's the app running. I'm going to put this side by side with Visual Studio so we can see code changes working. And then what we're going to do is let's again open up the home page and make some edits to our H1, add some exclamation points for excitement. And then actually, am I kind of cut off here on the left? I think I'm a little cut off. There we go. So you see this little flame button up here, up at the top. That's the hot reload button. If you click that, that will apply any code changes that you just made to the running application, and they will then show up in the browser, okay? You can also select an option down here to say, just go ahead and hot reload any changes I make whenever I save the files. And that way you just hit save and it will automatically apply the changes too. So that's how you can get set up in Visual Studio as well. I'm going to be using Visual Studio for the rest of the this learning session, but feel free to use the editor that makes you happy. All right, so let's start now looking through. I think if I go back to the Learn module, make sure I've covered everything. Where are we? We're here in creating our app, and we got it running. So we've done this. We can go ahead and now move on to the next unit to learn all about Blazor components. Let's look at the code for our Blazor components and see what they do. So first, in the Solution Explorer, in this components folder, that's where all of our Blazor components live. And we can see all the pages are, let me zoom in a little bit. All the pages are in this pages folder. Let's go ahead and open up the home page and see what it does. I'm going to stop debugging for now. So on the home page, you can see that most of this is just HTML content. There's an HTML tag here and just some HTML text down below. We've got a couple of Razor specific things up above. This is a Razor file, and Blazor components are implemented in Razor. Up at the top, we have a special directive, which is this @page directive that's adding a route, applying a route to this page. This is basically saying if the user navigates to / to the root of the app, this is the component that should render. We also see this weird tag here. This looks like an HTML tag, this page title tag, but it's a different color and it's capitals. What is that? That is our first example of a Blazor component being used from another Blazor component. You use Blazor components as HTML style tags that just have the name of that component. What is this page title component? That is actually a built-in Blazor component that sets the title on the HTML page. Like, so it shows up in the top tab. Like if we go, let me open up the app again. So here's the app. You can see up above that the title is currently set to home. If we go back to the code and change this to, home, home page, and we'll hot reload that, then you can see that the title has now updated to be home page. So this component is a little special component that lets you set the title from any component in your Blazor web application. Okay, so that's pretty simple. Razor is just a combination of HTML and also C#. We don't see much C# here yet. Let's look at the counter component. So remember, we saw the counter component. It had a button. We clicked it. The count went up. There's no page refresh happening here. The DOM is just magically updating. How is that working? Well, every time we click this button, it's calling C# code to increment the count. We can see that here on the counter page. Let's go through it. Up at the top, again, we have that page directive that is setting the route for the counter page, and see it's /counter. And that's why we're browsing up here to /counter to get to the counter page. We have this render mode directive. What is that? That's what's allowing this component to handle UI events. It's making this component interactive. And we'll talk more about render modes a little bit later. But the thing you need to know is that by default, a Blazor component will be statically rendered from the server. It's using static server-side rendering. That means that it gets a request, it renders some HTML in response to that request, and sends it to the response. And that's it. The component is done. That's what our home page is doing. It's just rendering this HTML to the response stream, and then it's done. An interactive component is a little different. It can handle arbitrary UI events like clicks and on-change events and all that stuff from the browser. and then run component code in response to those user interactions. That's why we say it's interactive. This component obviously is handling some UI events, so it needs to be interactive. That's why it has a render mode. And we'll talk about the different Blazor render modes in a bit. We talked a little bit earlier about, you know, the server-side rendering model and the client rendering model. We'll talk more about that in a little bit later. Okay, we have that page title component setting the title for the page, and then we've got normal HTML. Now down below, we can see a code block. This is another Razor directive @code that lets us add some code to our Blazor component. Now what happens with these Razor files is when you build the app, they get turned into a C# class. And that C# class basically captures the HTML strings that you want to render and all the rendering logic that you want to use for generating those strings, and any code that you put in this code block. So you can think of this code block as like defining C# members on a class, because that's literally what it's doing. We're just basically taking these members and putting them onto the generated class. So you can put fields here, properties, methods, you know, override methods on the component base, and so forth. We've got a single int a C# field for keeping track of the current count, a little bit of state for our component. And then we have a method that actually increments the value of the current count below. Now in our button, we're doing something cool here, which is we're wiring up an event handler for the on-click event. And normally you would, if this didn't have an @ sign in front of it, normally this would be like JavaScript that sits in this attribute. But because it's got that special Razor @ sign at the beginning, this is saying this on-click event handler is C#, and we're pointing to this C# method right there, just like that. So that is actually, whoops, I did that backwards. That is this method name, okay? And then up above, you can see that we're rendering the value of the current count field, again, using this @ syntax. That @ syntax says, take the C# expression that's after the @ and just render the value, okay? So that's how you can take any values from your code and add them to your HTML content. So that's how this is working. If we wanted to change what this component is doing, we could, for example, change the current count to increment by 2. Every time we click, instead of just by 1, the hot reload applied. Now if I click, it's incrementing by 2, okay? So that's how you can add some C# code to your Blazor components. Lastly, let's look at the weather page. So on the weather page, again, we have a route /weather. So that should be the case. If I go to weather, yep, there it is. It's at the /weather route. And then we have an attribute for, we'll talk about this in just a second. Let me come back to this. We're setting the page title and then HTML content. Now, thing I want you to notice here is that in Razor syntax, you can use normal C# code in your rendering logic for control flow. So if you want to conditionally render something, like I only want to render this p tag if some value is true or false in my code. You just write leading at, and then if. And if we have the weather forecast data, like if it's not null, then if it is null, then I want to render this p tag right here. Otherwise, we're going to do something completely different. We're going to do whatever's down here below, right? And what is that? So if we do have the weather forecast data, this is saying, well, let's render a normal HTML table. And down below, we see another example of C# control flow where we're going for each. We're just doing a loop. And this is useful when you want to generate a bunch of HTML tags in a list, in a row. So we're just looping over all of the forecasts in our weather forecast array, which is defined down here below in our code block. And for each one, we're doing something pretty neat. We're rendering all the table row data for each weather forecast. And you can see that it is a full C# expression that you can put after that @ sign to render the value. This is actually going to render whatever this too short date string method returns. That's the actual value that will eventually be returned. You can dot your way to a particular value in the C# expression. Razor is pretty smart about knowing when the expression begins and ends. So you don't usually need to tell it hey, I'm now writing HTML, because it just figures it out. If you want to be explicit about where the expression begins and ends, you just put some parens around it, like this. And you can see that kind of, in my editor, they're turning purple. That's the Razor saying, okay, I get that the expression now is just this part. If it's for some reason not clear where the HTML then begins again. In this case, it's perfectly clear, so we don't need the the parens. Okay. Down below in the code block, there's that weather forecast array, and the weather forecast is a normal C# type. Like where is I think it's defined below. Yep, it's just a class that we're defining as a kind of a nested class in the component type. And then we have a method, this onInitialized async method. This method is actually an override. It's a special method that we call a lifecycle event. This is the method that's used to initialize your component after any like parameters have been set on it. So if you have initialization logic that you want to do on a component, you can override the onInitialized async method. There's also a synchronous version, just onInitialized, and that's where you can put code that will happen when the component is first created. And here we're not actually calling like a weather API, like we're not getting real weather data. So don't plan your next vacation based off of this weather forecast. It's simulating a long-running API call by just having a little task.delay, and then it's just generating a bunch of random weather forecast data in C# code, and that's what it then renders. Once the onInitialized async method completes, it will render the UI above. Now, initially, we'll be waiting for that delay to finish, for that simulated API call to complete. And what Blazor will actually do is, while an async task is running, while you've kicked off some asynchronous piece of work, it will go ahead and render the component up front. Like it'll give you a chance to render. And the reason why it does that is so that you can put something like loading ... or a spinner or something that lets the user know, hey, I'm doing some work, just give me a second. And then once the async task completes, and the rest of this code runs to get the weather forecast data, the component gets a chance to run again. And that updated HTML can then be streamed down to the browser, and Blazor will patch it into the DOM for you. So you get automatic, seamless updates as async tasks complete. That's what this stream rendering attribute up above is enabling. It's enabling you to render really fast up front while you have any sort of long-running async tasks running. And then after those tasks complete, to stream updates down to the browser and have them be automatically applied. And that all happens over just a single request. Like there's no WebSockets involved there. You're just sending updates down the response stream, and a little bit of Blazor code, and the client is taking care of handling those batched updates. Okay, so that's the home page, the counter page, and the weather page in our application. So we've talked about what Razor is, that convenient mixture of HTML and C#. Components are defined in .razor files using Razor syntax, and we talked about how those get compiled to C# classes. All right, how about using a component? Well, we've seen an example of using a component already, which is this page title component. Can we use other components? Well, each of these Razor files is a component. What if we want to add like a counter to the home page? Well, we can do that. It's just an HTML tag that has the name counter, like so. So go ahead and do that on your home page, and go ahead and save it, apply it, hot reload it to your running application. If we go to the home page now, we can see, in addition to the home page content, we've now got a counter on the home page, and it works. So it increments by 2, just like the other one does. And we still have the counter that's at its route, at the /counter route. So that's how you can add a component just as an HTML tag. If we wanted to have the weather component here on the home page as well, we could do that. And now we've got the counter and the weather components on the home page. Okay, let's play around with a couple of other little Razor things just to make sure we've got our mind around how Razor works. Like let's say I wanted to add a little.
Hey Dan.
Oh, whoa.
How about I know. It's all so exciting. It's all really awesome. We had a couple questions that I wanted to get to before you moved on to the next section.
Sure.
Does that work?
Yeah, let's do it.
All right, cool. Okay, so a couple quick questions. Just so we're all on the same page, does stream rendering work? Does stream rendering work with a client-side rendering app?
Streaming rendering is actually a server-side rendering pattern. Blazor can render components from the server or from the client. We're not actually running any component code in this app right now from the client. It's doing everything server-side. And by default, remember we talked about how components by default in Blazor in .NET 8, they do static server-side rendering. They will just get a request, generate some HTML, send it to the response. The only interactive component we have in this app right now is the counter component, and we'll look in more detail at how that works in just a bit. With streaming rendering, you can think of that as an enhancement, a progressive enhancement on a statically rendered server-side page. It's taking that normal pattern of get a request, generate some HTML, send it to the response, and just allowing you to deal for the case where generating the HTML is going to take a little while. Like I need to go query the database, or I need to make an API call, and I want to get pixels onto the screen fast. I don't want the user to have to sit there waiting for the response to come to the browser. The browser will otherwise just look blank with the spinning, and the user will think, well, is it working? With streaming rendering, you can send an initial render immediately with like loading ... or give me a second, I'm getting your data. And then once the any of those long running async tasks are done, like querying the database, getting the calling it a weather API, it'll render the component again as in another batch of HTML that will go down the same response. It's like a streamed update. And then there's a little bit of client-side code. Like there's actually, I mean, we can see it in this app.razor file. This is the root of our Blazor web app. You'll notice that we have a blazor.web.js script that's part of the framework that sits there on the client, and it sees those HTML batches coming in, and it takes care of applying them to the DOM for you. So it's an enhancement on server-side static server-side rendering. It's not really using any interactivity at all.
Oh, cool. Very cool. Okay. And then next question, are these Razor components what can be used in desktop apps as is, or would they need to be modified further?
Every component in this app that you just saw could be used as is in a Blazor hybrid app, where this is the pattern where you can take Blazor components and embed them into like a native mobile or desktop application and have them. What happens is they render to a local web view control within that app. So yeah, everything you saw here like would work just fine within a Blazor hybrid application. I think there might be an issue with the interactivity mode on the counter currently uses the like interactive server model, and I think Blazor hybrid currently in .NET 8 will say, hey, I'm not a server. I'm a client application, so I don't support that particular across the internet render mode. So you'd need to remove that render mode in a Blazor hybrid app because it's all actually happening locally. I think we actually plan in a future release to remove that constraint where we'll just ignore the render modes where the component would still work, but the render mode doesn't really make sense. So that you might hit that, but generally everything you've seen here should work in a Blazor hybrid app.
Okay, awesome. Cool. And then another quick question. Could we reference any project class inside a Razor component?
Yeah, great question. I mean, it's C# code, right? So feel free to use any .NET API from that code that you like. All the code in this app is running from the server. So any .NET code that would normally run from the server, you can call from that Razor component. You can think of a Razor component as a C# class. It's just a fancy syntax for one that makes it easier for you to write the HTML markup. When that Razor file gets compiled, all that HTML stuff will get captured in like a render method, and all the stuff in the code block will be captured as members on the class. And you just have a .NET class at runtime. And that .NET class can, of course, call any other .NET API. So yes, you can call any other API you'd like. When you're running your code on the client, like on WebAssembly, well, you again can call any .NET API, but you just need to remember that you're running in a browser on the user's machine. You're no longer on the server. So, like if you try to talk to the database from the browser, well, you can't connect to the database from the browser. Or if you try to call an API that's like, please let me modify the Windows registry on this machine. Well, browsers won't give you access to the Windows registry from within the browser security context. You can't do anything with .NET code in a browser that you couldn't already do with JavaScript. It runs in the same security sandbox and within those same limitations. But as long as functionally the API that you're calling would work from a browser, like making an HTTP client call, making a WebSocket connection, then it would work fine.
Okay, awesome. All right, I'll let you keep going. I just wanted to get those ones like cleared so we were all on the same page.
Sounds great. Okay.
Thank you.
So we added some components to our homepage, and so now we have a counter and a weather component sitting on our homepage. So great, we know how to use components. It's just using that HTML tag syntax. You can also pass data to, oh, actually, before we move on, I wanted to play a little bit around with Razor. Let's go back to the counter. Let's make sure we understand some things. Like, let's say I wanted to display a message on this page that only displays after the user has clicked 3 times. And let's go back to just incrementing by 1 here. So plus instead of plus equals 2. So how can we do that? Well, easy. We just put an if statement in our Razor code and say if the current count, and notice we get lovely IntelliSense, if the current count is like, I don't know, greater than 5, then we have a little block here. And now let's transition back to HTML by just starting to write HTML. Then we're going to put a p tag in here and say, you did it, something like that. Okay. So let's see if that works now. If we start, let's refresh the page. So we get our counter back to 0. So I would click 1, 2, 3, 4, 5, and then 6. You can see that the component now updates and conditionally renders that we clicked more than 5 times. What if we wanted to like display, the text click every single time you hit the button? Well, we could do that. So let's add a unordered list HTML underneath the button. And in here, what I'm going to do is let's loop for each, actually, let's do a for loop for int I equals 0. We're initialize a counter variable while I is less than the current count. We're going to do this for as many times as the user's clicked, I++, okay? Have our little block here. And then I'm going to render a list item that says clicked. Okay, so this should render clicked whatever the current count is. Like if it's 5, there should be 5 clicks. So as I click that, I should keep seeing a new click message show up. Does that make sense? Let's go ahead and hot reload that. And so now I've already got 6 of them. Let's go ahead and browse away and come back. Let's just do it on the counter page. It's a little cleaner. So 1, you can see click showed up once, 2, 3, 4, 5, and then we get the you did it below, and we can keep going. Okay, so that's some basic control flow in a component. The last thing that I think is covered in this module, we've seen how to use components. We've talked about code blocks. We should talk about component parameters. Sometimes you want to pass data to a component and use it as part of the component's logic. How can you do that? Okay, well, a component parameter is defined just as a public C# property with a particular attribute, with the parameter attribute. So for example, let's say I wanted to make it so that you could tell the counter how much to increment by. So I'm going to add a property here, prop. It's going to be called increment amount. All right, and by default, I'm going to set it to 1. And then to make this a component parameter, I'm going to add the parameter attribute up above. Okay. And then down below in my increment count method, instead of incrementing by 1, let's increment by increment amount, like that. Okay. So now we have a parameter, and the component shouldn't have changed any. Like if we go back here and just keep clicking, yeah, it's just incrementing by 1. Nothing's different. But if I want to set this increment amount to something different, we can now do that. On the home page, the way you pass parameters is as attributes, like HTML style attributes. And here we can type increment amount. We got lovely IntelliSense. And let's say we want this to increment by 2, right? Okay, and we can save that. And now if we click away so that we reset our counter and start clicking, that didn't work. What did I? Oh, did I not hot reload? I don't think I hot reloaded. There we go. So now let's refresh the page. What did I do wrong? Did I not pass it in? Increment amount to so increment amount, current count plus equals increment amount. That looks right to me. I don't know what's going on. Let's just try restarting that. Sometimes hot reload gets out of sync. And let's see if we can get this to restart. Okay, so now if I click, no, it's still doing 1. I must have. Did anyone see the bug? Who sees the bug? Increment amount. Parameter equals 1. It's set. Oh, of course. Sorry. So I'm on the counter page, and the counter is a route. Thank you, Jayme. Like we're not passing any parameters to the component when it's rendered as a page. We're only doing it on the home page. So it's only this one component that I've set it to 2. So here, yes, of course, it increments by 2. Great, awesome. So that's working. I'm able to pass a parameter value to my component. The thing that's cool to notice is that this parameter value is not just like an HTML string. It is a full C# expression. So like if we wanted to do like 1 + 1 here, a C# expression for an addition. Or actually, let's make it something different. Let's do 1 + 2. And we'll hot reload that into the running app. And so now if I click, you can see it's incrementing by 3 now. It's evaluating the whatever this C# expression is and passing that in. So you can pass variables here. You can dot into values on an object and pass that in as a parameter. You should think of the attribute value of a component parameter as a little window of C#. Okay? So that's how you can define parameters and pass values into your components. All right, I think we've now done all this. We did the counter, we looked at the code and figured out what it does. And I think we've even probably done most of the next unit, which is we added the counter to the home page. Yep, we did that. We modified it to add a component parameter and changed it to something different. In this case, they did 10, we did 2. So we're done with that as well. Okay. All right, let's talk a little bit more about handling events and then also look at data binding. We've already talked about rendering expressions. We've already talked about control flow. So we're going to jump down to this handle event section next. Now we've seen how to handle one event so far in our counter component. And remember, to handle UI events, this needs to be done from an interactive component. We need this render mode directive up at the top. Currently, we're handling this on click event, and you can pass in a C# method. In this case, we're passing in a C# method name. There's a couple of different ways that you can specify an event handler. You can do it by method name, which is what we've got here. That method can be synchronous, or it could be asynchronous. Let me get rid of this. Get rid of these control flow experiments below. So let's say instead of doing increment count as a synchronous method, let's do increment count async, and this is going to be an async method, so it's going to return a task and it's going to have the async keyword. So we're going to do some async work in here. What are we going to do? Let's just wait task.delay. This will be a sluggish counter now. It will only update after 1 second. Okay, and then let's change the method that we're calling up above to, instead of increment count, let's make it increment count async. Okay, we'll go ahead and apply that. Now, if we go back to the running app and we go to our counter page, if I click 1,000, then it shows up. Click 1,000, then it shows up. Okay, so now we have a slow counter. How to make your app slow is what we're learning. But the thing that we're highlighting there is that you can have event handlers that do asynchronous work, like make API calls or whatever it is, and you can just pass them in, specify them by name. You can also, instead of specifying a method name, if you want, you can just pass in a lambda expression right here in the attribute value. Like if we want to increment the current count, we can do that using a lambda expression. So this will just run this method and run whatever code is inside it to make sure that it's actually doing something different. Let's make it increment by 2. And this one, that dialog that popped up, sometimes hot reload has to restart the app in order to apply the change. And that's what that dialog was saying, is that you just made a code change that can't just be applied to a running app. I've got to restart it. And so it'll offer to do that for you. And if I click now, you can see, yes, it's incrementing by 2. So you can do a lambda expression as well. You can also get information about the event as an optional event argument to your event handler. And a convenient way to see this is actually to generate a new event handler. And you can just do that by typing whatever name you want. And then a code action should show up in Visual Studio that's like, hey, do you want me to generate you an event handler for that? And here it's offering to say, do you want an async one or a synchronous one? And then you can activate that by clicking the little light bulb or hitting control dot. So if I generate a new on-click event handler method, when you do that using the tooling, it will automatically provide the optional event argument for you in case you want to use it. You don't need it, as we just saw. Like if you leave it off, the handler will still run, but it is available if you want to bind it. So in this case, there's not much that's actually really interesting on the event arg. I think it's got like the screen position and that type of stuff. A more interesting case, let's revert this back to let's get rid of this guy and let's do another event that has some more interesting data. Let's do an input. So this input is just a text box. And what I want to do is I want to wire up an event for the onChange event. So any of the normal HTML events that you want to wire up a handler for, you just do on the event name and then make sure you lead with an @ sign so that you can point to your C# code. And so in here, I want to do onChange. Let's do that control dot trick again to bring up the code action and generate an event handler for onChange. And then what I want to be able to get the value of the input, and that's provided by this event arg. So if I do, actually, I'm going to put it up here in a string variable. So string text, I guess, and we'll make it empty by default. So if I want to take my text variable, my text field, I want to set it to whatever the value of the input is, and that's captured in this value property. Now, technically might not be a string, but in this case, I know it's a string, so it's typed as object, but I'm going to cast it to a string because I know that's what it's going to be. It's a text box. Okay, so I've captured the value of the input, and then let's render it below. Let's just create another p tag, and we'll render @text so that we can see whatever was in the input should show up below it when the onChange event fires. The onChange event should fire whenever you like tab out of the text box. Okay, well, let's put it in a div so it's a little formatted, a little bit easier, a little easier to read. Styling by div. Okay, here we go. Perfect. Not quite good enough. Class. Let's do class. Add a little bootstrap class to put a little margin up on top of it. There we go. Okay. Can't type today. Okay, so now we've got a text box. And if I type ABC, nothing's happened yet because we haven't tabbed out. But if I tab out of the text box, the onChange event fires. We're able to get the value of the input, save it in a field, and then put it onto the screen. Okay, so that's how you can get data about the events by taking in one of those optional event arg types. And there's different event arg types depending on the event you're handling, and the docs will tell you which ones to use. If you use the code action, it will just automatically generate the correct event arg type. All right, so that's event handling. Let's do how much am I doing on time? We're getting a little. Let's do one more. Actually, not. I was going to do mouse. You can do mouse out, mouse over. I was going to do that, but I think we'll skip that one. Let's move on to data binding and how we can now bind the value of our UI controls to code. Like right now, we have this input that when it changes, it sets the value in code. But what if I want the value of the input to also reflect whatever code change I make to the text variable? Like for example, let's add a button, and let's have this be called had the insert button press. That's why I was having trouble typing. A clear button. And what I want this clear button to do is have an on-click event. And we're going to clear that text value. So let's generate an event handler. We'll generate a synchronous one. And in here, I want this to do text equals empty string. So if I click the clear button, it should change the value of the text variable back to the empty string. If I trigger the onChange event in my text box, it should set the value of the text variable to whatever text I typed in. Okay, let's see if I can hot reload that. Okay, so now if I do, let's see, if I do 1, 2, 3, tab out. Okay, that worked. I tabbed out of the input and it populated the text variable. If I clear it, okay, so I cleared the value of the variable, but the input is still 1, 2, 3. The state in the DOM didn't change. If I wanted to change the state of the DOM, I could do that too by setting the value attribute. This is just normal HTML attribute. And if I set it to whatever the value of text is, then I now have what's called a two-way binding, right? Like whatever the value of text is will appear in the input. And whenever text changes, the input would change. And when I change the value inside the input, it will also change the text value. Does that make sense? It goes both ways. So let's go ahead and add that. And so now if I type in and tab out, okay, we've set the text variable. If I clear, you'll notice that it clears both the input and the variable. Okay, so that's a two-way data binding, but there's a better way to do this in Blazor. This is kind of manual. Instead of writing all this code, what we can do instead is say, you know what? I just want to @bind the value of this input to text. And this will do that work for you. It will set the value of the input to text, and it will also listen to the onChange event and set the value of text to whatever the value of the input is when it changes. Okay, and so this should work exactly the same way. I do 1, 2, 3, or it doesn't really matter what I type. And then I get clear, the binding is working, and so the code is much simpler. And now we can get rid of this onChange event handler because we are no longer using it, and that should still work too. So boop and clear. Okay, so that's data binding. It's a way to bind the value of UI elements to your code. Now, in this case, by default, it's using the onChange event, just like we were doing manually. But what if I want it to be a different event? What if I want that to happen like as I'm clicking, like as I'm typing on the keyboard? Can you change the event? And the answer is yes. The way you do that is by saying @bind::event, and then you specify what event you want to use. Like, let's say I want to use onInput, which is like onType. And save that. And now as I type, you can see that the value of text is being updated as I type, and I can still clear it. Okay, so that's data binding. It's a way to bind UI elements to your code. Any questions about that, Jayme? I haven't looked at the chat.
Mute myself there. Okay. Yeah, we do have some questions actually, so happy to get through those. Okay, so I'm going to start with the older ones. It's either from a little far back. Can I use early return with if instead of if else in Razor?
Early return and if. What is early return? Is that like I'm not sure what that refers to. I mean, if it's C#, it should work.
That's what I was thinking they are referring to. But Tamer, Ali, if you want to clarify your question, I'll go ahead and ask that again. Another question that we got is, can component parameters be any type?
Yes, they can be any type you want, any .NET type. And remember that when you pass the value of a component parameter, it's a full C# expression. You have that little window of C# inside that HTML attribute. And so that might be a full object. We could pass in a to-do item instance, a product instance, or whatever you'd like. If you can have your component parameters of any type you want.
Awesome.
I believe, yes. We'll just leave it at that.
Okay, cool. Okay. Is the increment amount text or an integer?
It is an integer. So let's look at that code, because that was important and interesting.
Screen up here.
Yeah, let me bring up my screen real quick. So here you can see the increment amount is of type int, right? And when we passed in a value for the increment amount, remember I could even like set it to like 1 + 2, or whatever integer value I could generate for using a C# expression. So yeah, it was a full integer value.
Cool. And then another question, how to pass a function as a parameter to a child comp?
Oh yeah. Well, okay. So you can pass you can have a component parameter that's just like a func type. Like the C# has types that represent like delegates, which is how you represent a method that you want to call in C#. And there's even a special type that Blazor provides called an event callback. Like if we look at what was it? Let's go back to counter. This will be a little ugly to see, but hopefully we can see it. So this guy here, let's see if I can zoom in. All right, so the type of this on-click directive is expecting this thing called an event callback of T, of a mouse event args. And that's a type actually you can use in your own code. You can define a parameter on your component that's of type event callback. And then you can do the same thing that I was doing with onClick or with that on input, where you can pass in a method name, you can pass in a synchronous method or an asynchronous method, one that takes an event arg, one that doesn't. You can basically have components that have their own custom events. We just published a full Blazor learning series on YouTube. And I go into actually like building like a little custom button component that has its own onClick component parameter that you can use to pass in a method to the component. You can actually even also do data binding with a component. You can define a pair of parameters, like the value that you want to be bindable, and then like an value on change parameter for when it changes that Blazor can then use for like binding values to stuff that's a parameter on your component. So you can do data binding with components too. It's a little more advanced, but it's possible.
Very cool. Very cool.
All right. We should keep going.
Okay.
We're gonna get to this Connect 4 app.
Yeah, I was like, I want to build this game app.
Let's do
All
it.
right.
Okay. So
let's move on.
I think we're gonna let's take everything we learned and we're gonna quickly build a little to-do list app first, and then we're gonna move on to Connect 4. Okay. So what I want to do is like let's figure out how we can create a little simple to-do list, and we want to do it on a new page. So I'm going to add a new component to my app. I'm going to add it to this pages folder. And this, by the way, if you're following along, this is in the tutorial. After we get through data binding, you can just go ahead and click next. And this should take you to this exercise of setting up a to-do list page. So we're going to work our way through this tutorial and then pretty much be done with that module. Okay, so let's add a page to our Blazor app. And let's call this to-do.razor, like so. Okay, so a new Razor file. If you're in Visual Studio Code, just create a file and make sure it has a .razor extension. And I want this to have a route, and we saw how to do that with the @page directive. And I want this to be @/to-do. Okay, and we can leave the rest of the code. And if I add that, I'll reload that in. Okay, is that gonna get picked up? Can I now just browse this? I don't remember if I have to restart the app or not. Can I browse the /to-do? Nope. So let's go back and actually do a restart. Sometimes I think we have a feature that we want to add where you can actually add routes and apply them to the app using hot reload, but I don't think that's currently working. So dotnet 9. So /to-do. There, we have a new page. It's good. We went to a route and we now see our to-do component. I would like it to show up on this left-hand side along these other tabs. Where's all the rest of this content coming from? Well, this is your layout. This is it's actually a component itself. It's a layout component within which the other page components are being rendered. And we can see that in the layout folder. So here's main layout.razor. This is the only thing that's special about a layout is that it uses @inherits to say the base class for this component should be layout component base. And this is just like in C# when you inherit from a base class. This is just the way that you do it in Razor. And the rest of this is normal HTML. We're using a nav menu component here to render the left nav. But then there's this one special property on layout component base called body that we can use to render to say where do we want the actual page to go. So like our home page, our weather page, and counter pages will all go right here into this section. Okay, so that's our layout. This nav menu component is also in the application, and this is just what's defining those nav links on the left-hand side. Each of these components also has a companion razor.css file. So you can have style sheets that are specific to a component that just sit alongside them. Just name them .razor.css. And these are just normal CSS style sheets that style elements within those components. So this is where that gradient is coming from and all these little icons and all that stuff. So to add another link, what I need to do is just copy one of these existing links from the nav. We have there's the nav. We're just going to add another one. And we'll call this, the link will go to do, and we'll give it a name of to-dos. Okay, we'll keep the same icon that the other one had. Let's save that, and voila. So now we've got a link that we can click on in the nav menu. If we click around, yep, we can get back to our to-do page. All right, that's cool. So now we've got our page all set up. Let's add some to-dos to this thing. In order to create to-dos, I want to define a new class. I'm just going to define it right here in the component. It probably should be in a separate file, but for simplicity, I'll put it right here. So public to-do, a public class to-do item, and we'll give this a couple properties. So we'll have a Boolean, a string title property, and a Boolean is done property. Okay, so whatever it is you're trying to do and whether it's done or not. And then I need some state in my component to keep track of my to-do. So I'm going to add a list of to-do items. Okay, and I'll call it to-dos. And I'll just new this up to be an empty list. Okay, and then to render my to-dos up above, we'll create another unordered list like we did before. I'm going to loop over each to-do, for each var to-do. in to-dos, and we get some IntelliSense there, nice. And then I'm going to generate a list item for each to-do. And for now, I'm just going to take the to-do and I'm going to render its title property. So there's a C# expression. So this should render the title for each to-do that I have in my list. And if we save that, currently we don't see anything. Well, that's because we don't have any to-dos. We need to actually add some to-dos to our list. So we need a way to some UI for adding to-dos. To add a UI, let's add an input down below. Okay. And we'll add a button that'll be like add to. Okay. And so the input is where we're going to put in the title, and then add to do should add it to the list. Now for the input, I'm going to bind that to, let's create a new string variable below called new to do. This will just hold the value of the input so I can add it to my to-do list. By default, let's just make it the empty string. And I'm going to bind my input to the new to do variable. Okay. So now whatever's in this input should be in this string and vice versa. And then what I want to do is have a @onClick handler on my button. We'll call the method add to do. We'll use that nice little code action to generate an event handler for add to do, which is below. Actually, let's put it above the class. Put the class all the way at the bottom. Okay, and what do we want to do in here? We want to check. Let's see. Make sure that you just didn't like accidentally hit the button when the text box is empty. So if the is null or white space the new to do value. So we're checking if new to do is just empty. If it's not empty, put a bang in front. Then we will take that to do and add it. So we'll take our to dos list and say add a new to do item, and we will set its title to new to do, just like so. Okay. So that should allow us to add new to-do items to our list. And then whenever an event happens, Blazor automatically re-renders the components. That's sort of a heuristic that it has. Like if you have an event handler, it assumes you probably changed something in this component. Let me re-render it for you. And then we should see it show up in our unordered list. And we probably also want to clear out actually we should put it up here. So new to-do equals empty string. Let's make sure that we can start fresh. Okay. I don't know. I think I lost my connection with my browser. Sometimes that happens. Just go ahead and restart. All right, are we up and running? Okay, yeah, we got our little UI. Let's make sure it's running. Yep. Okay. So now if I write in here like learn Blazor and click the to-do, add to-do button, it's not working. Why is it not working? Do you remember we said that components by default are statically rendered from the server? If we want to handle UI events, they need to be interactive. So we need an interactive render mode. So let's go ahead and add render mode. And the right render mode to add is interactive server in this case. We're only using server-based interactivity in this app. Today we're not going to deal with client. This is the pattern where it sets up a WebSocket connection and handles all the UI interactions over that connection. All right, cool. So that should now work. Let's see if we can add some to do. So learn Blazor, add to do. Oh, did I not restart? Did I miss something? Let's see if anyone can find my bug before I find it. I just need to restart the app. There it goes. Okay, I just needed to restart. So learn Blazor, get some sleep. Right. Okay. So we're able to now add items to our to-do list, and they're showing up in the unordered list. Now we don't have any checkboxes. We got to have checkboxes in a to-do list, right? So let's go back into this list item, and instead of just rendering the title, let's render an input of type checkbox. Okay, like so. And this will just be bind it to do dot is done. Okay, so we're going to take whatever this checkbox is, and it's going to be bound to the is done property. Let's also make the title editable as well. We'll just have a normal text box, and we'll bind it to the title. Now, to be able to tell that this is actually, I keep losing my browser connection for some reason. Let's make sure that this is actually working properly. Let's up here above in the title we're going to just add some parens for just content, but let's display the count of to-do items that are not yet done. Okay, so I'm going to take let's switch to C#, and I'm going to take our to-dos list, and we're going to count each to-do where to-do is done is false, right? We'll put a closed paren around it just so it has some framing. So I need a lambda expression. So we'll take the to-do, and if the to-do is not done, then we'll count it and we'll display the count up above. Okay, and apply that to the running app, or restart the app if you need to. Okay, so right now we have no to-dos, so we don't have any that are not done. If I write learn Blazor, all right, we've got one to-do that's not done. If I check the checkbox, the binding works, the component re-renders, and now the count is 0. If I say eat lunch in here, you can see that we now have one to-do that's not done. And then uncheck things and check things and edit the titles. All right, so we made a simple little to-do list, and that is the end of module 2. Oh my goodness, we only have 20 minutes to build a Connect 4 game. We're gonna have to move. All right, so that is done. And I think we're going to skip this knowledge check. I'm going to trust you all to do the knowledge check and make sure that you correctly learn these concepts. I think you'll do fine. You all look like highly attentive Blazor students. So I think you'll be okay with this. But once you've done that, you should be able to unlock your achievement because you have built your first Blazor web app and learned the basics of dealing with Blazor components. Awesome. All right, let's go on. We're going to build a Connect 4 app now. Okay, we're going to use the things that we've learned. We're going to have some more complicated C# code, do some fancy CSS styling, and build the Connect 4 game. Let's see if we can do this. We're just going to move a little bit quickly just so we get within the 2 hours. But remember, the Learn module is always there. If something goes a little too fast and you need to go back, by all means, go back and read through the module and really deeply understand what's going on. Okay, so we're going to create a Connect 4 game, and let's go ahead and get started. Now, we've already learned what Blazor is and what WebAssembly is, so we're going to skip this part. We know how to set up Blazor components and what they are. One little trick that's kind of fun here is that this app will use, that we haven't talked about, is a way to, we talked about how to set the title in the page of the component. In this, there's also a head content component that you can use to add stuff to the HTML head of the page, like if you want to add some style elements or whatever. So head content is a component that you can add some styles from a child component to the page. We'll use that in just a minute. We've already learned about routable components, so I'm going to just skip all the way to Unit 3. Now we have our Blazor web app already. We're just going to use the existing one. Well, should we create a new one? I think we can just use the existing one. They'll be fine. We'll use the existing one. And we need to create a new component to represent the Connect 4 board. If you haven't played Connect 4 before, it's just putting in tiles and trying to get 4 in a row. And if you can get 4 in a row horizontally, vertically, or diagonally, then you win. You're just taking turns with another person. So let's add another component to our application that's going to be called board.razor. And for right now, we'll just start with some empty content. Okay, so let's go back to Visual Studio, and we'll do right-click, add a new component. We'll call this board.razor. Right, and I'm just adding it to the components folder. It's not going to be a page. It's just going to be, a standalone usable component. And we'll just leave this content in there like that. And then I want to add this to, let's add it to the home page. I'm going to get rid of the content that we've had here before. And we'll just have board right here on the home page. Okay. And hopefully that applies successfully. And if we go to the home page, we should see our board component being rendered from the home component. Okay, there's our empty canvas for us to work with. Okay, and now let's go pull this out into a separate tab. Make a little, maybe I do this and get Visual Studio on the side. And then where's the tutorial instructions? We want this guy is where we're actually working with the board, and I'm going to put you side by side with my running app so that I can quickly just move back and forth between them. Just a little screen window arrangement so we can be as efficient as possible. All right, so we've got the board component now added to the home page. Check. All right, now we're going to add a bunch of, we're going to add some divs and some spans to the page that are going to be used to draw out the Connect 4 board with the the circle spots for each of the pieces. So you can just copy this HTML into your board component. If you want to get to your board component's code, a convenient little trick is right-click, go to definition, and then we're back. And I'm just going to copy that right in. This is pretty straightforward. It's just generating a couple of divs, and then it's using a loop to create 42 spots for pieces on the board. The board is usually, I think it's like 6 circles high and 7 circles wide. So 6 times 7 is 42. That's where that number comes from. Okay, so we save that. I'm saving the web page. If we hot reload that, we don't really see anything show up on the page because these are just empty divs and spans, but they should be there. You can probably check for them in the browser dev tools. All right. And now we're going to add that head content trick that I'd mentioned before to just add a little bit of styling to the root of the app. Let's put that right up here. Okay. So this is just going to set up some CSS variables that will set up the color for our Connect 4 app. And I'm actually going to change this yellow to gold because I find the yellow on a white background is just like really hard to look at. Okay. And still nothing showing up yet because we're not even using those CSS variables. Okay. Now to get all those divs styled to look like a board, we're actually just giving you a existing CSS style sheet that you can use. And so this is just like one big long line of CSS styling that you're just going to copy and paste, but you're going to do it in a component specific style sheet. So in your Solution Explorer, what you want to do is add a board.razor.css file right next to board.razor. Now, I know you probably would like to just be like right click and add it there, but don't do it on the file. You want to do it on the folder because VS only knows how to add files to the folder. So add a new item, and we'll call this board.razor.css. And then VS will nicely nest that next to the other one because it sees that the names match. And then you can just copy the CSS styling from the tutorial and then put that in. And this is some pretty fancy CSS. I'm not a CSS expert by any stretch of the imagination. I do very basic CSS. But if you look through here, you'll see like the div.board setting up the size of the board. And then those spans for the containers for the circles. Here it's like, setting the border radius to 50% and doing some CSS trickery to make it work. So let's go ahead and see if that just works. Let's just reply that to our running application and ta-da, CSS, it's magical, I know. Well, all we did was take the divs and spans, apply some CSS to make them look like holes in a yellow rectangle. Okay, great. And you can look through this if you're curious to know exactly how it works. So we've gotten to that point. We can move on to the next unit. Let's go to the game logic unit. Now, the game logic for this Connect 4 game is pretty simple. When the component loads, we want to reset everything so that the board is empty. We want the users to be able to click on something to put in pieces into each of the columns, and the pieces should fall down through the columns and land on whatever row isn't currently occupied. And they should go back and forth. Like there should be a player 1, player 2. They trade turns until someone wins, like until they've got a full 4 in a row. So we'll have a game loop that will drive this game. And the way you do this in web development is you want to make sure that the state, the logic that you're representing is separate from your UI presentation layer. We're going to take that game loop and encapsulate it in like just a C# class that's not even related to Blazor at all. It's just a class that knows how to drive a Connect 4 game. And it's not this one. This is just an example of a game state object, but we're going to have one that specifically represents a Connect 4 game, and then we will bind that to our UI elements and have a nice separation of UI and game state. To reset the game state, we'll use onInitialize. That's the first thing that happens when a component loads. And so, in onInitialize, we're going to want to reset the state of the game. And then, of course, we'll handle UI interactions using the UI event handlers that we learned about earlier when we were building the to-do list app. Okay, so this is just setting up the principles about what we're going to do. To actually do it, go ahead and go to the next unit. All right, so the game engine for Connect 4, we're just going to give you the code. We're not actually going to code that live. So go ahead and download this gamestate.cs file. You can just click on it, and then save as, download it to your machine. I've already got it saved, so I'm just going to use the one that I've already downloaded. Download it and download the file, and then just right-click on your project and add an existing item. Mine's in my downloads folder, and there's our game state object. And if you want to look through this to understand how it works, that's totally cool. It's got some properties that are tracking whose turn it currently is, tracking whether someone has won the game yet. Here's the logic where it's evaluating whether someone's actually won, figuring out if there's 4 pieces in a row for horizontal rows, vertical columns, forward diagonals and backwards diagonals, and a check for win condition based on that logic. And then down below, there's a method that you can just called play piece, where you tell the engine, hey, a player, whoever the current player is, just played a piece in this column. Okay, so that's all the logic we need. We need an instance of this game state to use in our board component. And the way we're going to make it available is through dependency injection. We're going to make it available as a configured service. So go into your program CS file. We haven't looked at this file yet. This is just the entry point to your Blazor web app. This is what's setting up the ability to use Blazor components within an ASP.NET Core web application, which is itself just a .NET console application. We're not going to go through all this code in detail, but up above, you can see there's a section that says, here's where you add services to your container, where you want those services to be available through dependency injection. And all you need to do is do builder.services.add Singleton. We're going to add our game state class, I guess, as a Singleton service that will be available through the app. What does Singleton mean in this case? It means that they're just going to be one instance. Whenever someone asks for the game state service, they're going to get an instance, and it's always going to be the same one. That's useful for if you just want to have global state for the entire web application. You can also have things be scoped or be like per instance, where every time you ask for a service, it gives you a new instance. And in this case, we're just going to have one instance, and it's always the same one. All right. Now, how do we get this game state service into our component? Well, in our board.razor file up at the top, we use another Razor directive, which is @inject. And this is kind of like defining a property. You define the property type that you want, the service type that you want, which is game state. You may have to resolve a namespace to do that. I just did control dot and used a code action to add a using directive up above for the game state namespace. And then you do space and give the property a name. And so I'm just going to call this state. Okay, so Blazor will then automatically inject the game state instance into my board component, and I can just use it as if it was a property on my class. That's pretty cool. All right, so that looks pretty good. Let's see where we're at. Let's go back to we've got our game state. We set it up as a game state instance, and we injected it into our Connect 4 board game. All right, well, easiest thing to do actually is to now do the reset. Like, let's reset the game whenever the component is initialized. So go ahead and copy this onInitialize method and add it to your code block. OnInitialize will be called whenever the component is created. Okay, good. So that looks like that's still running. So every time we refresh this page, we should be resetting the game. Okay, now we're gonna create some more DOM elements for each of the individual pieces. All we have right now is a board. We need like things that we can render on the screen that show the blue circles and red circles. So we're gonna keep track of all the pieces on the board using this pieces array. So just go ahead and copy this into your code block. It's just an array of strings. And then up above, we're going to render 42 pieces, just as spans, on the page that will then the CSS styling will make look like circles. Okay, and where do we put this? We put it in the same component, and it looks like we want it inside the div, right below the board class. So right in here. Okay, so now there should be 42 spans kicking around on this page. We don't see them because they're not currently they're display none by default, and they only show up when we actually change their styles to make them visible. All right, great. So we've got all of our pieces now, at least in the DOM. And now we need a way to actually like add those pieces to the screen. So we're going to add a method to our board component for playing the piece. This is going to be our event handler for when the user clicks on the screen. So go ahead and copy this code, and you can take a look at it real quick at what it does. It takes the column number, 1, 2, 3, 4, 5, 6, 7 that you want to use for which column the user selected for playing a piece. It figures out which player's turn it currently is, player 1 or player 2. It also keeps track of like how many pieces have been played by the current turn is the current turn count. And then it tells the state object, hey, I want to play a piece, and then I want to play it in this column. And the game engine then takes care of understanding, okay, there's a piece there, and the turn has now switched to the other player. And then it builds up a string based off of those values. And this is just like a CSS class string that we're going to render onto the spans for each piece. And the CSS style sheet that we added will then know, oh, okay, so this is player 1 or 2. So it should either be blue or red or whatever, what color we've picked. The piece should go into this column, column 1, 2, 3, 4, 5, or 6, or 7. And it should go into this row. And this row is coming from the game engine. The game engine is telling us that piece was put in that column and it landed in this row because it's keeping track of all that state for us. Okay, so we've added that method. We don't have anything calling it yet. How do we get something to call it? Okay, so we're going to need some buttons or something to click on to actually add pieces. So up above the board, we're just going to add a nav with a bunch of little like icons that represent, like, if you want to play a piece here, just click the little icon. Okay, so let's add this, we'll copy this code and put it right above the board. I think it goes right there. Let's see if that works. It looks like I have to restart my app to get it running again. No problem. All right, so now you see I've got these little like icons sitting above each column. And if we look at the HTML for that, you can see there's an on-click handler that when it's called, it's calling play piece, and it's passing in the column, and it's capturing the column number from this for loop. Like it's looping over, 1 through 7, capturing the number for the column, and then just passing that in through the event handler. It's a cool little trick when you have use the Lambda expression, of how you can like pass in a parameter to the actual event handler. Well, not to the event handler itself, but to a method that the event handler then calls. And so that should work. Let's see if that works now. So if we go to the app, and if I click on one of these things, oh, it's not working. Why is it not working? You remember this? We're using event handlers now. We need to make the component interactive. Now, cool little trick that I'll show you for making a component instance interactive. If we go home, instead of putting like, at render mode, like this up on the top, which really ties the render mode to the component definition, we can just make the board itself interactive, just like by putting an attribute on it. And so that means just this board instance is now interactive. Okay, so that way you don't have to like, we could put it in the board component itself, but then the definition of the board is tied to interactive server rendering. What if you want to do it on the client? What if you want to render it a different way? This is the way that you can apply the render mode to the instance, as opposed to having it live in the definition. All right. Let's see if we can get that to work now. Can we click on things now? Aha! And this is cool CSS animations, something that I'm very proud of whoever figured out how to do that. Okay, so you can like click on things and now apply a piece. All right, so that looks great, and the game engine should be keeping track of whether someone has won. So if I put a bunch of pieces in and do 4 in a row, and then let's say I try to put another piece, oh, we got this like error at the bottom. Well, currently the game engine will throw an exception if you try to play another piece when the game is already done. So we need some like status, like showing us whose turn is it? Is the game over? And a way to maybe even reset the board. So that's what we're going to do as the final step. Okay, so we got the pieces playing. We've done all this. We need to have something that keeps track of the winning state, and even error handling. Like, what if someone like let me refresh the board. Like, what if someone just keeps clicking and keeps putting pieces in this column until there's too many? Again, the game engine throws an exception. We should let the users know, like, hey, there's already too many pieces in that column. You can't add another piece. So to do that, we're going to add a little article section below our nav. Let's go back to our board component. And just below the nav, we'll add just some UI that tells us whether anyone has won. We're gonna have a button here that we can use to reset the game if you decide you just want to start over. Right now you have to like hit refresh on the page. What if you just want to, you know, stop that game and begin a new one? We'll have a button for doing that. And then we'll have a span for displaying an error message if the user tries to like add too many pieces to a column, and then also tell the users whose turn it is. Now, you have red squiggles over all these things because we haven't added any C# state to keep track of it. Let's add some code, which is right down here. Let's add a bunch of fields to our class, and I'm just going to copy over the existing string array for our pieces, and this is what we'll keep track of: the winning message, the error message, whose turn it currently is, and whether the reset button should be visible. Like, we only want the reset button to be visible really after someone has finished their game. Okay, that looks good. And then we need an on-click reset game handler. Let's see, where is that? I think that's a little bit down here. Down here, we'll add a reset game method that allows us to clear off the board, and we can put that below the play pieces method. Okay, so that should wire everything up. Now we need a little bit more logic in our play piece code to actually, you know, change the values of these fields so that they reflect the right things. And we can do that with a little bit of a exception handling. Oh, where is it? It's a little above here. Yeah. So we're going to add a try catch around our play piece logic that will detect if the user's done something wrong or if they have already won the game. Okay, so error message is initially empty. If there's an exception, then we'll display the error. So now if I just add that, I think I should be able to at least trigger, let's refresh. If I do that thing again where I just click a bunch of times, aha, yeah, it tells me the error, and I even can see whose turn it is. I also want to display when the game has been won. And for that, I think that is just a little bit further down here. Yeah, we'll add this little switch statement into our play piece method. I think this goes at the bottom. Yeah, so we will update the winner message based on whether the state object tells us that the game has completed or not. And it gives us this sort of like a enum thing. Like, it tells us which player has won and whether it's a tie, because that could be a possibility as well. And so that should then trigger up above, like we'll check to see if the winner message is not empty. And if it's not empty, then it will make the reset game button visible. Okay, so let's see if that works. Let's go back to the app. So we can see whose turn it is now. And so now if I play the game, and let's play a very naive game to see what happens when we win. I'm going to have player 1 win, and our reset button now shows up. If I click the reset button, it's now a blank screen, a blank game again. We can play all over. So that is how you can build a simple Connect4 app using everything that you've learned so far with Blazor. There is one more step to the exercise that I'm not going to go through just as we've hit time. But if you go to the next exercise, there's a little bit more you can do to like customize the colors of your Connect4 board to make it look however you want using component parameters. Make sure you go ahead and do that. And that is what we've got for you today. You're just one step away from finishing your third Blazor Learn module in just a very short period of time. So yeah, Jayme, what do you think? Oh, whoop.
What about now? Okay, that was a whirlwind. Amazing. You actually got it built in time. So amazing. Congratulations to everyone who was able to build it online as well. Please do go and complete your Learn modules, get those points. We also have a survey about this event, about future Let's Learn events, also about your developer journey. We really want to know about you and where you're calling in from and how Blazor is working for you. So please fill out this form. And let us know. We'll get some important metrics that we utilize for future events. Thank you so much for joining us here today. If you're unable to join this event in English, we also have translated and localized events for this same content. So go to the page and look for those. And yeah, thank you so much and have an awesome rest of your day. Thanks,
Great job, everyone.
Whee! One of these will be my thing.
I think we're still live. Hello.
Yeah. No, I know. Okay, thanks. Bye.